The last bit of this section, it's still 1.3. What I like to do with this stuff is kind of do it a little bit differently than what you see in the book, a little bit differently than what you've probably learned in the past. We've talked about midpoints. We've talked about segment bisectors. We've done all of the algebra with it. We've done the idea of starting at one point, going halfway, and figuring out how much further we have to go to get to the end. We've done all of that. So what we want to do today is figure out how far is it from here to here. So if I need to figure out how far something is, if I'm on a number line, if this is -2 and this is 5, how far is that? 7. They're 7 spots apart from one another. If I do the same idea, if this is -12 and this is -5, how far apart are they? They're still 7 apart. Because the distance, when you walk a distance, no matter where you are, will your distance ever be negative? No. So what we're going to do today is we're going to talk about distances. And not only will we be talking about distances that are what would be considered a horizontal distance, or if I'm working on a set of ordered pairs that are vertical, again, if this is 14 and this is 7, well, take a different number. How far apart are those two? 8. So the distance between the 2 points is 8. But what happens then when they're like that? Here's what happens. We're still going to figure out the distance, but we do it a little bit differently. Ladies, how are you?
Great.
Good. It's good to see you. Did you have a good day at KEC today?
Yeah.
Sweet. I'm just going to do this. It's no different than any other day. I got the pile of homework. I got the pile of homework on your stuff right there if you want to.
Easy.
We're not using these now, so
Just using it for time. We have homework.
So here's what's going to happen. The way that I like to show these things is I like to start with ordered pairs. For example, -3 and -4, and let's say 2 and 6. And when I do this, we missed you. Joke. Oh, I don't mean it. That came out badly. I'm sorry. So what I want to do here is, I don't want you guys to graph this, but I want to show you what's happening graphically. So when I graph these things, just so we have an idea, -3, -4. -3, does that go left and right or does that go up and down? Left and right. So I go -3 left, and then I go -4 down. And the other one is at 2 and 6. And I want to figure out how far apart those are. The problem is, I can't count diagonally. The units themselves are not the same for each one of those squares. So what we have to do is we have to come up with a way to figure out the distance between those 2 points when they're on a diagonal. Basically still using counting. For example, if you notice that if I drop this part down and then I cut over to the left, what does that create? A triangle. More specifically, what kind of a triangle? A right triangle. Good. Now, do you guys remember a little something about right triangles? There was one really important theorem about them. You're getting a little ahead of yourself. What was the really important theorem about triangles? What is it? The what? You all know it. Then help her out. Pythagorean. What's the Pythagorean theorem? I know you guys all know this. What that basically tells you is that the horizontal distance squared plus the vertical distance squared equals your diagonal squared. The change in x values, that's the x value differences. This is the differences in y values. So if you know how far apart your x's and your y's are, you can find out how far apart the points are. For example, when I do something like this and I'm looking at a graph, one of the easy things I can do is count. This is really difficult, so trust me, you have to pace yourself. Put your phone away. Ready? 1 little, 2 little, 3 little spots, 4 little, 5. What?
Nothing. Keep going.
So how far apart is -3 and 2? They're 5 units apart, right? Okay. Now we count the other one, the y values. Ready? 1 little, 2 little, 3 little spots, 4 little, 5 little, 6 little spots, 7 little, 8 little, 9 little spots, 10 total spots. How far apart is -4 and 6? 10 spots. What are you laughing at? You've never counted like that before?
No.
Seriously? You guys got to get out more. So what I'm getting to here is knowing that this distance here is 5 and this distance here is 10, I could then basically utilize Pythagorean theorem to find out the hypotenuse squared. Put your phone away. You're not that good at hiding it. I know, just put it away. So, 5 squared. 10 squared. 25 and 100 is? So right now this tells me that 125 is equal to c squared. How do you undo taking a square root? I'm sorry, how do you undo squaring? Square root. Now here's what's great about this calculator. When you use this calculator, you take the square root of 125, it gives you a simplified radical form. It tells you that the answer is 5 root 5. So this distance here is 5 root 5. And that's what we're going to be doing. You're going to have all of your answers in terms of simplified radical form. If you don't know how to do the simplified radical, or if you don't have that calculator, hey, you got to get one, or you have to know how to simplify your radicals. Okay? That's kind of what we're getting at here. All right? It's not that it's difficult, because I know you've all done this before, or you've done it like this. What was the order here again? 2, 6. Now, when we talk about the difference in x values, that's when you would take 2 minus the -3. Second x value, subtract the first. We squared it. Second y value, subtract the first. We squared it, and then we took the square root of it. Remember that? That's the distance formula. The distance formula is the Pythagorean theorem. All you have to do is count. You don't have to use the formula. You can, nothing wrong with it. The distance formula it is basically the Pythagorean theorem. That's all it is. Your distance formula is the square root of the change in your x values, your horizontal change, quantity squared, plus the change in y values, the vertical change. Every time. It never changed. Where did all my erasers go?
He stole them.
Well, I actually have markers today, so I'm not worried about that. Ray, would you mind handing me that eraser?
Eraser over here.
Thank you, sir.
Probably took your
Look, you
eraser
have one
too.
right here.
Yeah, it's almost closer. And I know all of you guys have used this formula before. This is a very generic Algebra 1 topic. There's nothing to it. What I want you guys to be able to see is that sometimes it's much easier to do it when you just count. You did all that counting yesterday. Why not just keep counting? Let me show you another one. Do the same idea. Shh, ladies, come on. I'm going to find the distance between these 2 points. And in order to find the distance between these 2 points, I can do one of 2 things. This is my sad face. How far apart is 2 and 4? 2. So these two are 2 apart. I got to square that. How far apart is -7 and 0? 7. I have to square that. And then I take the square root. What's 2 squared? What's 7 squared? 49. And you're done. Those of you guys that have that multi-view calculator, one thing you will notice is that, I was trying to do it. If I type in the square root of 53 and it spits out square root of 53, that just tells me that there's nothing in there that can be simplified. Whereas when we did that square root of 125, it came out as 5 root 5. That meant that there was a perfect square hiding within it. In this case, there's no perfect square. Yes, ma'am?
I thought we were putting those into that thing.
It does the exact same thing.
Yeah, but how come my calculator gave me square root of 11 then?
I might have had operator error. Because if you do that, change the next value is 4 minus 2. 0 minus the -7. Here you have 2 squared. Here you have 7 squared. It's still 4 plus 49, which is the square root of 53. So
My calculator's just stupid.
it's not stupid. You might have pressed the wrong button. Let me see what you pressed. I can tell you what you did. What did you forget to press?
Oh. It's me.
But here's what I want you to do. Don't try it. Hey guys, this is a great learning part here. Don't try and throw the whole thing in the calculator at once. Break it into smaller chunks so you don't forget to square something or forget to put a symbol in there. Just, it's not that it's a really difficult math thing. It's just be careful with it. Just take your time. That's all. Careful. All right. So it works both ways. Does it matter what you use? No. Personally, I think it's easier to count. It's like counting money. It's easy. Well, we'll try. Give me a number.
I can count mine.
Give me a number. 30? Give me another number.
2.
Give me another number.
45.
Give me another number.
17.
All right, let's find the distance between those two. How far, with the ordered pair is 30 and 2, 45 and 17. How far apart is 30 and 45? 15. How far apart is 2 and 17? 15. So now you have 15 squared plus 15 squared. 225, I think? Which gets you, which should be 2 root 15. Oh, I'm sorry, 15 root 2, excuse me. That's it. It was 15 root 2, right?
Yeah.
You okay? I accidentally wrote it
It
backwards.
looks like this.
It's when the marker writes, sometimes it leaves those things. But remember, 15 squared is not going to be 22 and change. Okay.
So that's the answer that we were done with answer?
Yes, ma'am. That's all it is. As you go through these things, we're going to use what are called exact answers. We're always going to use simplified radical form. Yes, ma'am. I need to. Why don't you grab the green thing? Okay. So when you're using these simplified radical forms, that's what you have to use. These calculators here, excuse me, these don't do it. That doesn't do it. The only ones that winds up doing it are the ones that are the multi-views. The multi-view calculators are the ones that would use simplified radical form, guys. That's why I've been telling you. It's unfortunate the others, people that have sold calculators in the past and the other buildings always kind of say, hey, you should get this one. No, you don't need it. You don't need it. No big deal. All right? One more. Give me a number.
4.
Somebody else give me a number.
3.
Negative 28.
Loud.
What's with you guys in these 15 distances? That's 3 in a row.
That's their fault.
How far apart is negative 8 and 7?
You put 4. You put 4. It's you. It's all you.
They're 15 apart. The distance between those two is 15.
I didn't say something. Someone else said 7.
How far apart is 4 and 3?
1.
Remember a second ago we just did 15 squared? 225? Now, pace yourself here. I know it's boring him to death. What's 1 squared? 1. So 225 and 1 is? Now if you press the button in your calculator, what does it spit out?
What was
Did 226?
Okay.
Did you-
Hey, you steal my calculator every time you do this, right?
Second.
Oh, and I'm not. Oh, thank you.
Oh, just for giggles,
This one.
what happens if it ever does ask you to do a decimal approximation with this type of color?
Don't
Do you know how to
do it.
change that? Ladies, please. Do you know how to change this one to a decimal?
It's that little arrow button above that, right?
Correct. Hit the double arrow button, and it'll automatically convert to decimal for you. So anytime you have like a fraction, you want to change it to a decimal, sometimes it does, it'll ask for a decimal form or anything with that calculator. That double arrow button switches it from simplified radical form or whatnot into decimal equivalencies. Okay? All right, the other example I have for you is actually on a piece of graph paper. Just wanted to show you guys how to do this again on a graph.
He's not sorry to let that
Yeah, because I was in the back when I picked them up, so I just walked away.
I think we start doing that. No, it's usually in the front of the room.
One of these days I'll pass them sideways just to mess with you.
Oh, no.
I'll be right there.
She's like, I think. Okay, maybe again, I will find one.
So take a look at number 12. It's on the second side. I know. You guys can find out. As you guys know from the people in the back of the room, I rarely, if ever, count because it's just too hard. It takes too much time to count all the pages that we have to go through. So, again, you guys obviously aren't very good at singing the song. So we need to learn the songs so we know how to count correctly. Because I am not one to leave you guys behind without the ideas of counting, because I want to make sure you're vocal and happy and you can annoy people, because it's fun. So, we got to figure out from here to here, which means we have to figure out some horizontal and some vertical change. So we count. Ready? 1 little, 2 little, 3. Come on, ready? 1 little, 2 little, 3 little spots, 4 little, 5 little, 6 little spots, 7. Okay, that's 7. Now we count the other way. I need full people singing like you really care. Otherwise, I'm gonna make you sing out and stand up in front of everybody.
Is this a PBS special?
Sure. Ready? 1 little, 2. Come on! Come on! 1 little, 2. You guys all. All right, ready?
Start over.
1 little, 2 little, 3 little spots, 4 little, 5 little, 6 little spots, 7. So how far is the change in x? How far is the change in y? So it's 7 squared plus 7 squared, and take the square root. So 7 squared is
49.
49 plus 49 is 98. Dun dun dun. 7 root 2. The calculator does it for you. Now, if you don't have one of those calculators that does the square root for simplified radical form, if you get to the point where you take the square root of 98 and you leave it like that for right now until you get that, or you borrow somebody else's, that's fine. But I just want to show you guys that all we're doing is counting. That's how easy this stuff is. Let me show you one more. Now, all the graphs that we've done, counting-wise, all seem to have a positive slope. Do you think it's going to change if we have a negative slope?
No, because it's just,
Right.
you can't walk negative 3 miles.
Correct. Now, the only thing I will warn you guys of is 11. The only thing I'm going to warn you guys of with these problems, sometimes the scale on the graph might be going by 2s. So instead of singing 1 little, 2 little, you might be singing 2 little, 4 little, 6 little spots, or 3 little, 6 little, 9 little spots, 12 little, 15 little, 18 little spots. It just goes on and on. It's great. So let's count. Ready? You gotta sing like proudly. None of this. This is stupid. Have fun with it. It's like you're going home in an hour and a half anyway. Who cares? Ready? Let's go. 1 little. Come on! You gotta sing. Loft house.
Why are you saying?
They're not singing.
Why are you saying 1?
Look where the 2 is. The 2 is on the second one. 2, 4. So it's 1, 2, 4. All right, ready? 1 little, 2 little, 3 little spots, 4 little, 5. What are you wondering about? Again. 1 little, 2 little, 3 little spots, 4 little, 5 little, 6 little spots, 7 little, 8. So once you change next, you change y. 5 and 8. I know this is the dumbest thing in the world to do it this way, but it works. 5 squared is?
25.
8 squared is? And you're done. Can't do anything else. It will not simplify from that. I'm just making up words as I go. Do you think the idea, well, aluminium is the correct pronunciation. Aluminium, if you're in Europe. Do you think anything changes if you count a line segment that's vertical? If I count a line segment that's vertical, do you think it changes? From here to here? I'm sure there are still spots to count. It's just a vertical change. The horizontal change then is going to be what? 0. So all I have to do is count. Do you want to count it?
No.
Do all these, please. You'll be done in like 10 minutes. You missed out on a scene.
Good job.
All right, air quotes. She missed on singing. Yes, ma'am.
So, when we only draw the triangle, that's when like sideways.
You can do it anytime.
What about this one like?
Does it, when it's just a second. Yeah, so the horizontal is 0, so it's just count. How far apart is it? That's it.
What am I doing? That's the same.
Does that segment look like it's 0? Hey guys, real quick, because you're being silly on this here. In this case here, is there any horizontal change?
No.
So all we have to do is count. Ready? 1 little, 2 little, 3 little spots, 4 little, 5 little, 6 little spots, 7 little, 8 little, 9 little spots, 10 total spots. So, do you want? That look is awesome. You're like, get me that out of here. So, do I need to use Pythagorean theorem for that? Could I? Yeah, because it's 10 squared plus 0 squared. which is still 100, and the square root of 100 is still? Dun, dun, dun. The plot thickens.
Oh my god.
I'm not lying, guys. All you have to do with these things is count them, use Pythagorean theorem. You don't need necessarily use the distance formula. If you want to, that's fine. It does the same thing. It's just trying to make your lives easier by counting. All right? You got about, what, 12 minutes or so? You should knock over 75% of this done just by finishing up. Give me 1 second to stop this and I'll be right there.
Are you just doing the back or what?
Doing the whole thing.